Hello, boys. Good morning. Hope all of you are well. We are just having online classes for last couple of months, and by this time we have finished our syllabus. We have reviewed our chapters, and the review class is continuing. And we have just participated in two in-house model test term, and next we will just next we will participate some other test, and then our board exam is our final motive. Today I will discuss a creative question from chapter 13, modern physics and electronics. As all of you know that from this chapter there is a very poor chance for coming questions, but as this is a major chapter of physics. For knowing physics, you have to know about modern physics and electronics, and sometimes questions come from this chapter also. So we will try to solve the questions. We will try to review all kind of questions from this chapter. Here is a creative question, and the same is: radium is a radioactive isotope. Its atomic number is 88, and this type of radioactive substance emits alpha, beta and gamma ray spontaneously, and this is the stem. And according to this stem, the questions are: what is doping? Question number B: describe Edison effect. Number C: if the alpha ray in the stem has wavelength of 10 inverse 13 centimeter, find out the frequency of the ray. And question number D: if the half-life of above isotope is 12.5 years, what amount of atom will remain after 25 years? So what is the question number A? What is doping? As all of you know about, you have already known about doping, how doping is done. What is doping? The addition of some definite elements in order to increase the conductivity of a semiconductor is known as doping. Doping is mainly done for increasing the conductivity of semiconductor, and pentavalent or trivalent material are used for doping. And from doping we just get the p-type and n-type material. So here I have to mention only the definition here. So the addition of some definite particles or elements in order to increase the conductivity of a semiconductor is known as doping. Question number B: what is Edison effect? In 1883, all of you know that Edison, he has a very crucial participation in inventing the lights or bulb type material. So in 1883, Edison observed that in a light bulb, a current can flow through a vacuum space from the filament to a metal plate. This process is known as the Edison effect, and using this effect or this concept, the light bulb or the source of light was just generated, and this is called Edison effect. That means in a vacuum space, a current can flow through a filament to a metal, and following this mechanism, lights were produced. Our question number C: in question number C, the wavelength of the alpha ray is given 10 inverse 13 centimeter. What will be the frequency for this? As we know that the relation between frequency, the speed of light and wavelength, this is a very common equation: C equals f lambda, and where f is the frequency, and from this equation we can easily find the wavelength of the frequency of the alpha ray. So here wavelength is given in the unit of centimeter. We will convert it into SI unit, that will be 10 inverse 15 meter. And as we know that velocity of light is 3 to 10 to the power 8 meter per second, and then we can easily measure the frequency from here. F equals the quantity will be 3 into 10 to the power 23 hertz. And we will proceed to the question number D. What is our question number D? Question number D is, if the half-life of above isotope is 12.5 years, that means the isotope mentioned in the stem was radium. The half-life of this radium is 12.5 years. And what amount of atom will remain after 25 years? As you know that half-life means the total time that is required for getting the number of atom totally be half of its initial atom, and for getting the number of atom into half from its initial atom, the time is required, that is called the half time. So we have to measure the half time here, or half life. No, half life is given in the question, that is 12.5 year, and we have to measure what amount will remain after 25 years. If 25 years is gone, then what amount of atom will remain? We have to measure this one. So we can calculate this one with two different ways. First of all, if we just use the equation n equals n naught e to the power minus lambda t. In our regular class, I have just told you about this equation and what are the quantities here. Here the initial atom n naught is initial atom is denoted as n naught, and in our question number of atom is 88, that means n naught equals 88. And then what is n? Remaining part of atom is denoted by n. We have to measure this one. Lambda is called decay constant. We can measure lambda by using another equation. Lambda equals 0.693 divided by t half. That means there is a relation between decay constant and the half-life. And time here is given 25 year, half-life is given 12.5 year. We have to measure only the remaining part of atom. So in this equation, that means n equal and not e to the power minus lambda t. In this equation, we just don't know the value of decay constant or lambda from our stain, so we can measure this one by using lambda equals 0.693 divided by t half, and using the value of half-life, we can get the value of decay constant 0.055 per year. As we have got the decay constant, now we can put this value into the first equation, that means in n equals n naught e to the power minus lambda t, and we just get the value of n equals 22, and there will be no unit for this one. Remaining part of atom will be 22 according to our calculation. So using this equation, we can just determine the remaining part of atom, but using another short technique, we also determine this one. We can also determine the remaining atom by using a small technique. Here, first of all, we have considered that the initial atom is 1. Fine, at first the atom was not decayed, so let's consider the initial number of atom is 1, and for getting half from 1 to half, the time is mentioned in the stain 12.5 year. So for getting half, it takes time 12.5 year, and from the amount half for getting one fourth, it will take another 12.5 year. That means after getting after decaying half portion, the remaining portion is again divided by 2. That means from half to half portion, we are just moving to one fourth of the atom. So from getting half to one fourth of the atom, the total time will be 12.5, and 12.5 year equal 25 year. And if we then divide it again, if the decay is continued here from one fourth of initial atom to 1/8, then as it is divided by 2 again, that means another 12.5 year will be required here, and we will add with the previous 25 year, and 25 plus 12.5 year, the amount of time will be 37.5 year. So from this chart, we just can have a conclusion that from initial value that was considered as 1, from initial value for getting half, or for decaying half amount, the time is 12.5 year. From that half amount for decaying to one fourth portion of initial value, the time is required 25 year. From one fourth of the initial value for getting 1/8 of the initial value, it takes the time of 37.5 year. But in our question, the time is mentioned 25 years. So according to the list here, according to the table here, the for 25 years, the remaining atom will be one fourth of initial one. Initial value was 88, that means one fourth of 88 is 22. So by following two different rules, we are just observing that the values are same for the number of remaining atom. You just can solve this type of question applying in any one method as you wish. So boys, this chapter, that means the chapter number 13 and chapter number 14, physics to save life, there is a probability of coming question in upcoming exams, because in last years or last couple of years there was not any question, any full CQ type question from this chapter. So as these chapters are new to you, so there is possibility of coming questions from this chapter. So don't try to avoid this chapter, as you have to appear on the board exam, on the test exam. So you have to complete the whole syllabus. You have to have a good command on the whole syllabus. You have no chance to skip any chapter. Finally, whenever you will just take preparation for the board exam, then you can make choice or make some preference for some specific chapters. But now, as you are reviewing all chapters, you have to complete all chapters and all type of questions. So boys, today's class is just finished, and in our next class we will try to just explain some other creative type questions. And if you just have any problem regarding to any chapters, you can share. We will try to discuss from question from those chapters. We will try to discuss some questions from those chapters. That's all for today. Stay safe. Goodbye.